Welcome back to the Ascend Devlog. Previously, we looked at the birth of a new game. A fast-paced action roguelite with the player on a quest to ascend a vertical cyberpunk city, facing off against ruthless factions like a mafia syndicate, a singularity-worshipping cult, a slavers guild running cruel sci-fi gladiatorial games, and other horrors. We looked at an early sketch of the world design, then built out a prototype, starting with our second level. Check out my previous devlog explaining why I'm starting with the second. Our hero, last we saw him, was just a red capsule, but today we're going to upgrade him with a real face and body and some animation too. I'm pretty new to animation, so in the process, I managed to produce some truly head-scratching bugs. You know the saying, don't talk about the sausage, just show the results? Well, I'm going to have to break that rule today. Today's episode is all about the
icy sausage rise.
Our Cumberland sausages.
Pork sausage.
That's right. We're going to talk about the quirks, the challenges, the bugs, as well as the solutions from a programming perspective. There's a lot to explore. Let's dive right in. The first thing to do is to look for some assets. A lot of you probably know about this website, but I just discovered Mixamo, and it's great. Browsing through their catalog, I found this model called the Alien Soldier. He looks very cyberpunk to me. I also found this 3-hit animation, so I downloaded it with plans to touch it up, make it a bit more snappy, less like a barbarian and more like a ninja. At this point, I'm going to gloss over a few other changes I made, so we can focus on the two big challenges from the sprint. But to give a quick rundown, I reattached all the movement controls back onto our Mixamo model. Added in cross-platform support for both keyboard and controller using Unity's new input system. And upgraded our bullet to use a better bullet model, trail render, and also object pools. This way, instead of constantly creating and destroying new bullets were simply activated or deactivated from a larger pool. With those out of the way, I was ready to tackle the first challenge, aiming the gun. On the last devlog, the player could only shoot in the direction they were facing. Here's what that looked like. But of course, we want to be able to aim wherever the mouse clicks, and turns out that's a bit more complicated. The main reason is the game happens in 3D space, but your mouse moves in 2D space. So we gotta convert the 2D coordinates to a 3D coordinate. I drew a little diagram because I had trouble wrapping my head around this at first. Please excuse my Photoshop skills. So you have your 2D monitor space here that your mouse cursor moves on, and behind that, with the camera looking through it almost like a window, is your 3D game world. I began looking for tutorials on how to do this. Surprisingly, there weren't many good resources. Most tutorials with top-down shooting dealt with 2D, but I did find an approach using main camera.screenPoint to Ray. It's a function and it takes your mouse position as an input. What this does is it shoots out a ray from your camera intersecting through the position of the mouse cursor into your 3D game world. Great, I thought. Now it's just about finding the intersection point where that ray hits the ground and sending the bullet there. Or so I thought. This was the first thing I tried. I took the ray from the camera, looked for where it intersected with the ground, and if it hit anything, I activated a bullet from our bullet pool. Pointed it towards that point of intersection, accounting for the height of the gun so we weren't shooting into the ground, and off it goes. And this worked. Kinda. I began noticing a strange bug. As you can see, the bullet shoots perfectly when it's going straight north and south, but as you start to drift closer to east and west, there starts to be more distance between where the bullet shoots and where your mouse cursor clicks. This will be very confusing for the player, and I had no idea what was causing this bug. My first thought, I kid you not, was, this is it. I'm a fraud of a developer. I knew I should have paid more attention in geometry class. No, of course not. I wasn't ready to give up, but I also had no idea where to even begin searching for something like this. Thankfully, I came across a tip suggesting Raycasts could be debugged by making them visible. This was a great place to start. After looking at some sample code and a few false starts, I managed to get the Raycast to show up. And looking at it, I still wasn't sure where I had gone wrong. It wasn't clear if the bullet was aiming towards the point I wanted it to on the ground, or if it was off. That is, I wasn't sure if my initial logic of sending the bullet to where the ray intersected with the ground was sound, but my execution was flawed, or if my initial logic was flawed to begin with. So after poking around a bit, I tried a different angle. Here you can clearly see the ray does indeed intersect right through the ground. I slowed my bullet speed way down so I could get a good snapshot of the bullet in close proximity to the ray, and okay, so it does look like the transformer of the bullet intersects where the ray touches the ground, so my execution is good, but something must be wrong with my initial logic. And then it hit me. Why, of course, the camera, it's at an angle. If the camera was looking perfectly straight down, the bullet would go exactly where the ray is. Alternatively, even if the camera's angled like it is right now, if the bullet was flying on the ground, it would also go where the ray is. But because both the camera's angled and the bullet is about 3 units high in the air, when seen from our angled camera, the distance between the bullet and the ground is what accounted for the visual difference. But how would I go about fixing this? I knew somewhere in the universe there was a math formula that would calculate how many degrees from true north my mouse is, and compensate the angle of the ray based on the angle of the camera tilt. But for mere mortals like myself, such knowledge was completely out of grasp. So I had to come up with a simpler solution, a kludge solution. What if I raised the ground? Not the ground the player's walking on, but if I created a second invisible ground, sort of trigger box. So I tried that. I made a second box, made it very large to encompass the whole level and anywhere you could possibly click. Then I gave that box its own layer. In Unity, when you cast a Raycast, you can tell it to only intersect with objects tagged with a certain layer, so that's what I did here. And then I compiled, click play, and crossed my fingers. And holy shit, I think it worked. Wow, I couldn't believe my eyes. That did it. Usually debugging feels like fixing one thing and breaking down 2 more, but this?
Against Indy. They've almost degraded into it.
Well, it felt pretty good. That defect was closed. Now I was ready for the second challenge, 3-hit melee combo. If the first one was difficult, this one had me really scratching my head. I had already downloaded the 3-hit combo, so now it was about splitting it up into separate animations and setting up the logic flow inside Unity's animator. Basically, there's a variable called attack combo that starts at 0 and increments by 1 every time the player clicks attack. At 0, 1, 2, and 3. If at any point the current attack animation finishes but the player has not clicked attack again, we revert back to the idle state. I also wrote a script to work in tandem with my animator. By the way, I want to give credit for the original idea to a tutorial on Medium called Making a Hack and Slash Game by Mina P. It's a great tutorial and I put a link into the description. Our setup wasn't exactly the same, but it was close enough that I based mine off hers. The central premise is the use of coroutines. Coroutines is a way to pause the execution of a chunk of code until a set amount of time has passed. For example, in my bullet pool, after each bullet was activated, I set a coroutine so they would deactivate after 4 seconds. During those 4 seconds, the rest of the game continues to run, as the coroutine does not block execution elsewhere. The same concept applies here. We have a coroutine that waits for 95% of the duration of the animation. If by the end of that time the player has not clicked attack again, we return to the idle state. However, if the player has, we cancel the currently running coroutine, increase our attack combo variable by 1 so as to move on to the next animation, and restart the coroutine with 95% of the duration of the current animation. We also check that our attack combo variable has not increased past 3 since we only have 3 hits to our combo. There's a bit more happening, but this is the gist of it, and it's totally cool if you don't get all this. I certainly didn't the first time. After playing around with the code a bit, I got it to compile, and eager to experience my new masterpiece, I clicked play, and oh boy, it was a mess. While running, my character wouldn't attack, And once he did start attacking, he finished the 3-hit combo and began gliding around like, And randomly, while attacking, he just wouldn't stop. This was not gonna do. I thought I had followed the tutorial pretty closely, but clearly I'd missed something. So I strapped on my big brain programmer's hat and began debugging. I must have tried about 10 different variations, reworking and tweaking, but whenever I fixed one thing, 2 more broke. We were back to this. After about a day and a half, I had to back away and take a break. This bug, or more likely, this series of bugs, was clearly more deep-rooted than I thought. Whenever I hit a programming problem I got really stuck, I always think of 2 things. The first is many years ago, when I first began as a junior in a software firm, I would often face bugs that would defy all logic and physics and gravity and just refuse to be fixed. But whenever I resolved these bugs, I looked back and realized I always learned something new. There was either a piece of the framework I didn't know about, or an algorithm that did something slightly different than what I thought, or a tool or plugin or concept that I'd never heard of. So, when faced with this situation, I took a deep breath and told myself, Entropy, you're about to learn something. The second thing is an interview with Glenn Schofield, creator and director of the Dead Space games. There's a particular section of this interview that left an impression on me. He says it better, so I'll just play the clip.
When I came back, nothing was working, but yet all the stuff was there, right? And it was done right, it was done good. But they're like, Glenn, we did everything you asked, but it's a mess. And I'm looking at it going, yeah, it is, it is. After just kind of making a whole bunch of mistakes for a couple of weeks, we realized there's got to be a better way. And I realized that, the problem wasn't the team, it was really on how I was giving them their assignment. Some things need to come first. I need to have him grab him by the leg before I can throw him on the ground. And he needs to be on the ground before I can start animating. So all these things then started coming in as layers. So, started thinking about how the heck do we get the tentacle to come in, grab the leg, picks him up, throws him on the ground, the sound hits. Realized I had to do one thing at a time. All right, guys, just animate the drag tentacle coming out of the hole and it grabs him by the leg. And they're like, yeah, but the sound's like, just do that part. Came back, that worked. Then we came back and said, okay, the next thing, animate him being picked up and thrown onto the ground on his back. And they're like, yeah, but then he shoots. I'm like, no, let's just do this part. Now everybody was starting to get it. Oh, when you do everything at once, you're not sure why it's not working. When you layer it and you break it down, you peel the onion peel, and you keep, you add one, you add one, you add one, and then you hit a spot where it's not working. Now you can focus everybody just on that spot and get through it a lot quicker. I started calling it layering. Layering management. There's probably a term for it, but that for us, we still call it, we gotta add layers. We gotta do this in layers, guys. And nowadays, most of the guys on my team will know that this is a layered problem.
This was definitely a layered problem, and it was time to peel back the onion. I looked at the footage again and focused only on the first problem, not attacking while running. Combing through the code, one section jumped out at me. I had the running animation triggered inside fixed update, which ran about 50 times per second. Yet my attack animation was being binded through Unity's input controls. There was a race condition. If the player was running and attacking, the trigger for the running animation would go off before the trigger for the attack, and override it. So I added a Boolean variable to keep track of if the player had clicked attack, but the code hadn't yet had time to trigger the attack animation. This was only about 10 or 20 milliseconds, but during that time I prevented the jump animation from taking precedence. This worked. Now we can attack and do one swing. But any more than that and we were back to a spaghetti mess. Okay, no problem. Next onion layer. My hunch here was something was wrong with my code routine. I tried a bunch of things, but then I decided to completely reformat the code. I still had the code routine wait for 95% of the duration of the animation, but I created a separate variable, keeping track of whether the player clicked attack during that span. If they did, we moved on to the second attack animation, and if they didn't, we returned to the idle state. That was it. Nice and simple. I was convinced this would work. Yet still. I began to suspect it wasn't my code that was the problem. I posted a simplified version of my code onto Unity's forums, and other developers confirmed it did work for them, which was reassuring. So, what was I missing? There was one piece of the puzzle that always felt a little off to me: the animator. So I took a pause from the code and I went and watched 3 tutorials back to back on the animator, focusing on melee attacks. Then I went back and combed through my animator again, and suddenly the problem jumped out clear as day. There was no return condition. Why, of course. With no return condition, by default the return condition was whenever the current animation finished. However, if the player clicked attack during that span, they would also proceed to the next attack animation, so Unity was given conflicted directions on whether to send the animation back to the idle state or onwards to the next attack. And herein lay my bug. I couldn't believe it. With excited and bated breath, I added some conditions, and look at that. Beauty. Is my code pretty? It's about as pretty as...
Your mama!
Sorry. Am I proud of it? About as proud as asking my crush out in 9th grade and getting brutally rejected in front of the whole class. That is, I'm proud I did it. I'm not proud of the execution. But does it work? Yes. Oh yes. It works. And that was it. After 3 days, I finally fixed the bug. I cleaned up my code a little bit, made some final edits to make the transition smoother and attacks a little snappier, and I was done. Now we have our attack. We have our shooting. Let's put it all together and see what it looks like. If you enjoyed this, please consider liking and subscribing. It helps the channel grow and it means a lot to me. Thank you for watching. This has been Entropy. Until next time.